Okay, so I'm going to look at PMOVMSKB to start with now. So let's just go to the encoder assembly and we'll do PMOVMSKB. So this one basically just supports register and then vector, but I'll be skipping this XMM one. These are all just going to use the 32-bit registers because they would do the same thing anyway, because they zero the upper parts of the register, and if you write to a 32-bit register in 64-bit mode, that zeroes the upper part of the 64-bit register as well. So although NASM will allow both EDX and RDX, for example, as a register here, I'll only use the EDX version because it's the same anyway. So here we'll do, for example, EDX XMM, let's say 3 or something. Then we've got a VEX version of this, and this supports YMM as well. So these are the only these are the only 3 encodings of this form that I'll actually be testing. So let's just make sure NASM's okay with that. Then we've got PMOVSX. So we've got BW, BD, BQ, WD, WQ, and DQ as the suffixes. These legacy ones all use XMM. Then VEX uses XMM for all of these ones here. But as soon as we get up to YMM, the source stays as XMM. Let's just check that's consistent down there. Then with EVEX, we've got, so source is XMM, XMM. With ZMM, it goes to YMM. For most of them, I think. This one, it goes to XMM. So I think what I'll do here is I'll try to get them correct and just copy paste and then let NASM tell me where I've got the incorrect sizes. So we'll start with a PMOVSX BW. So let's just go into here. We've got a PMOVSX BW. So this is RM encoding. So this is XMM0, XMM1, and then we've got a memory access. Then if we skip to the next BW, this one is the VEX version. And this supports YMM, but in this case, the source is staying as XMM. So we've got XMM here, and then if we go to the next BW, this is YMM, but the source is still XMM. Going over to the next BW in EVEX, this is XMM with XMM. Then we've got, where's the next BW? Next BW is, oh, it's just here. So it's YMM with XMM, then ZMM goes up to YMM in this case. And these support op-masks, so I can force the EVEX encoding by using some random op-mask. So in this case, we've got XMM, XMM, and then the ZMM one here needs to change the source to YMM. So that's BW. Then we've got BD. So BD here, XMM stays as the source for everything all the way up through VEX. Then with EVEX, we've got BD, which just uses XMM consistently as the source. Then we've got BQ. And in the BQ case, the source stays as XMM. Okay. Then we have WD. So in the WD case, ZMM goes to is paired with YMM, but the others stay as XMM. So in this case, that would change to YMM. Then for WQ, we've got XMM, XMM. This one stays as XMM the whole time. And then we've got DQ. So with DQ, ZMM goes with YMM. Let's just check that I've got that correct. Looks like it's okay. So that's SX. ZX is basically going to be the same thing, so I'll just copy these and change the SX instruction into ZX. Okay, that looks all right. So the next instructions I want to put in are also these PEXTR, BDQ, and then this is W1 as well. So this one I will be doing all of them. There's no MMX in here, so we'll do PEXTR B. So this is basically is it MVI or MRI? It's MRI operand encoding for all of them. So this one has register, and then with B the memory access is 8, with D the memory access is 32, Q it's 64, and I assume for W it must be 16 as well. So this one here, register, I think on this one, let's have a look at this. Destination register of 64-bit mode. I assume that with these, I can basically just use, so like for example, EDX. So let's just try this with EDX. This is register and then an XMM, so we'll just do XMM 5 or something. And then we've got an immediate. So that's okay. Then this needs to be a memory access of some kind. So because this is B, then this is automatically assumed to be a byte access. So I could annotate it like this to be more explicit, but I'll let NASM just sort of figure that out, because the mnemonics distinguish which instruction is being generated anyway. So that is the legacy encoding for B. Then we've got a VEX encoding, which is the same thing. And then we have an EVEX encoding, which is also the same thing. So to force, there's no YMM or anything in here, and there's no op masks or anything. So to force the EVEX encoding, I'll use 16, or maybe I should use a different one, like 18 or something like that, just a high register to force the EVEX encoding. So let's just go and check the listing for these. We'll just do a general check just to make sure there's no obvious duplicate encodings anywhere. Okay, that all looks okay. Let's go down to the extract one. So extract does not have any duplicates in there, so that's fine. Okay, so let's just copy this one. This will be the same for D and Q. But I think with Q, I'll probably have to change EDX to RDX. So let's just regenerate those. Okay, that's fine. Let's go to listing again. There's no duplicates in here. These ones are EVEX though. Is that because this doesn't have a legacy encoding? This one does have a legacy encoding, but we're getting EVEX encoding here. Why would that be? Let me just change. I don't think I can use EDX with this. Can I? No. This is RDX, XMM5, and then an immediate. So if we've got a prefix of 66, so this is 1, 2, 3, 4, 5, and then I assume 6, 7 bytes. Let's just regenerate that with the correct thing. Okay, yeah. So actually EVEX encoding is actually shorter, I think, than the... I think this is actually shorter. Oh no, this isn't EVEX. This is actually legacy. It's just I got confused with the 6.6 here. Okay, that is correct then. Okay. Yeah, 6.6 here. Okay, yeah. No, I was just getting confused because I was looking at 6.6 and thinking it was a 6.2 EVEX prefix, so that's actually fine. Okay. All right, let's go and look at PEXTR W. So this one has a few more forms in it, because it also accepts reg and rm, so it accepts rm and mr, or so this is rmi and mri. I don't know which ones NASM is going to select, but it looks like the forms will basically still just be the same thing. So I could probably just change these to W. Let's just have a look at the listings. Okay, yeah, so we got legacy, vex, and evex. Okay, so as far as I can see, so for example, this one, reg xmm immediate, is actually the same as reg xmm immediate here. It's just this one is MRI and this one is RMI. I don't know which one NASM's going to select, so we'll just see when we get to the forms. But it seems like that's all okay, and I think that covers all of the forms as far as I can in NASM anyway. So let's just do a copy of these and we'll change extract into insert. So this is PINSR. And this looks like it's the same. We got R. Oh, this is RVMI. So actually these are not copies, really. Okay, let's just do these ones from scratch. So we've got a P insert B. So these ones are, for legacy, we've got RMI. So we'll do XMM0, and then we'll do something like EDX, and then the immediate. Yeah, and they're separated by mnemonic, so I don't have to do anything like marking operands as explicitly being a certain size or anything. But this one has the middle operand 2 as the potential memory access. Okay, then let's just do the vex encoding for B. And then we also have the evex. So these ones are basically just adding another operand. So we've got, let's say, XMM1 here. So this one is RVMI. And then this is the same for evex, but I'll use a high register to force that. So let's just do the listing again. If we go and look at the listing, so we've got legacy, we've got vex, and we've got evex. So I think I can just copy these again for the Word version, because they follow RMI and RVMI anyway. So we'll just make a copy of these two. We'll go to this B1 and change this to W. This one changes to D, and then this one changes to Q. With Q, though, I think I need to use 64. So this, instead of EDX, this should probably be RDX. And we'll have one more look at the listings before we go and implement these, just to make sure that there's no obvious duplicates anywhere. Okay, I think that looks generally okay. Okay, so final thing for this is to take all of these and generate some test cases for them. So we'll just go and create the test notation, line it all up. For these ones, these should be X word and Y word. I think all of these other ones look okay. That should be okay. Let's just generate the listing one more time. And now we just need all the mnemonics. So we go all the way down to insert, take all of these. Let's go to the MOV mnemonics down here, and we'll just add them onto the end. So that's VMask MOV, we'll just put them on here. Let's deduplicate these. So I'll just separate these by like their suffix, I think. Okay, so insert all the way up to just below the VMask MOV. Let's put these into the name table. Okay, let's just go up here, take all of these as lines, remove the empty selections and add the strings. And then we'll just take these over to the forms table. So let's just create some empty forms for these. Okay, so PMOVMSKB, let's just do go test, this should fail immediately. Okay, so let's start with a PMOVMSKB, which is here. So this is a 660FD7 for all of them. So we'll match on width is X word, op n. For this one is RM, but op1 for this must be a general purpose register and op2 must be a vector. Then we had the prefix of 66, map is just the secondary one, and then the opcode I think was D7. So this is the same for the vector one here, or the vex one. So we've got family vex, and the same for evex, but evex, this one doesn't have evex, this only has vex. Okay, so let's just do the test again. So this is still not matching. Oh, this needs to match on Y word as well. Okay, so now we're on to PMOVSX. So PMOVSX is just going to be mostly the same as this one here. So we've got RM, I think, for all of these. Yeah, they're all RM. But these ones are just a little bit different. These are vector with vector or memory. Then we've got the map of 38 for this one. And the opcode is 20. And then this one is evex. None of these use W bits as far as I can see. And they stay the same. Okay, so we can just do family vex here. This should match all the way up until an evex. Could not match an instruction of form BW with vec and vec. Okay, this one should be Y word. Then we can't match the evex ones. So this has Z word, EVX, and this should still not match because I need to accept op mask and zeroing. Okay, so now we're on BD. So as far as I could see in those tables, we're just counting up in the opcodes for these. So this would be 21. Let's just copy this to here and do Q. This one is now 22. Then this was WD, I think. WD, BD, BQ, WD. This one was 23. There we got WQ, 24. And then we've got DQ here, which will be 25. Okay, so that moves us on to the 0 extension ones. So let's just copy all of these because they're basically going to be the same. We'll just replace all of these and change SX into ZX. And let's go look at ZX. So this is the same, but they're just changing from 0x2 to 0x3. So that's 3. Okay, so now we're on to extract B. So extract B here. And these we're just going to match on, well, they're all XMM, or, you know, like the size of the register or something. So maybe I'll just use X word just to keep it simple here. So let's see, extract B, this will be width is X word, the op n for this is MRI. Op1 can be a general purpose register or memory. Op2 can be a VEC, and Op3 can be an immediate 8. So this one has a prefix of 66 and a map of 3A. Then the opcode is 14. Okay, so it's not matching that still. Oh, this might be because of the tests. Let's just go to PEXTR. Yeah, so I'm just going to change all of these to be X word. And we'll do the same. Insert already has X word for all of them, so let's just regenerate those listings again. Okay, so now we're on to the VEX encoding of this. So VEX encoding is the same thing. We've got W0, but then Q uses W1. And EVEX is also the same. So we've got 14. Yeah, 14 and then 16. Okay. So EVEX for, so we want VEX and EVEX for this. So this is family is VEX. This one is only ever X word, and it's MRI encoding still. Is W the same? Yeah, okay, W had the other encoding, but I don't know which one NASM's going to select. So this one is still 14 here. Then we got EVEX. So now we go on to W. So let's just copy this for W. So with W, we've got 660F for for the register ones, so I wonder which one it's selected. Let's see in the listing. I would assume that it's selected the shorter one, which I think would be just the secondary opcode map. So we've got 660F, and then for the memory one, it's selecting the 3A opcode map. So let's just do. So we've got MRI here. Okay, let's just see which one doesn't match here. Okay, so for MRI, we want 15 as the opcode. Okay, and then these register ones. So let's just say we'll take a copy of this one. So basically, if it's got memory, we'll do 15. If it's just a register here, then we'll do the secondary opcode map with C5. So not quite right. PEXTR. We do have the secondary opcode map. Oh, okay, this is just going to be... so this is actually R MI. So this is a separate... they've switched around the operand encoding for this. Okay. And then we just need the same thing for these ones here. This one for EVEX, okay, so this is the VEX version that's that needs to change, I think. Yeah, VEX version needs to change a little bit. So we'll take this VEX one. We'll keep it the same as the other ones. So we'll do reg is on the top and then memory is on the bottom. So for the register one, it's still C5 with the secondary opcode map, and we're changing the operand encoding from MRI to RMI. Okay, so now it's onto the D version, which is going to be the same as B. So for this one, we've got 16. With no W bit set, and then for the Q version we've got the same thing, but the W bit is set. So Q here, the W bit gets set, I think, for all of them. So PEXTR. Okay, so this is actually not, we don't want to do this for the legacy one here. PEXTR. What we got is, oh, actually we do want to, okay. Why is that not, oh, this should be Rex, okay. Rex is Rex force W. Now it's on to insert. Okay, so I think insert follows basically the same pattern, so we'll just copy this and change it from extract to inserts. Okay, let's go and look at insert down here. So this is 3A with 2.0 and 2.2. So this one is to 0, and this one down here for D is to 2. And then insert W is C4 for all of them. I guess this one, these have a different operand encodings though. So actually, we need RMI and RVMI. So this one is going to be RMI. So here we have, instead of register or memory, we've got R is VEC, op2 is register or memory, and then op3 stays as it is. So let's just take these for D and Q as well. Replace all of these. Then W, actually D and Q, so for the VEX versions here, we've got our VMI. Okay, so this one should be our VMI, where op2 or op3 is the register or memory, and op2 is just another vector. Okay, let's copy these. And this op3 should be op4 now. Okay, so let's copy this operand encoding stuff down into the other VEX and EVEX encodings. Then for W, we have RMI and RVMI as well. So actually, we could probably just copy B for the W one as well, and just change the encoding. So this is C4 for everything. Yeah. So this is C4. Okay, so what have we got wrong here? We've got insert W. Okay, this has to be map is just the secondary opcode map. Okay, so that's some more MOV instructions, MOVMask, MOVEXTEND, and then insert and extract.